My computer crashed and took the TV and the refrigerator with it. You know, I absolutely love this quote from a cartoon stock comic because it just perfectly captures that modern, low-level panic we all feel when our smart devices suddenly decide to stop being smart. We've all been there, right? Staring blankly at a frozen screen, wondering if our whole digital life is about to unravel. It's a super lighthearted take on our everyday tech frustrations, and it's funny mostly because it feels so incredibly relatable.
Welcome to The Explainer. Today, we're shifting gears from the low-stakes satire of everyday computer crashes to a staggering, incredibly high-stakes reality. We are going to break down the July 19th, 2024 CrowdStrike incident. Now, this wasn't just a single laptop giving up the ghost. It was an unprecedented global digital disaster that literally brought major industries, airlines, and businesses to a complete standstill.
So, here is our roadmap for today's explainer. We'll start with the universal blue screen, then move on to the July 19th outage, dive inside channel file 291, look at the mismatch 21 versus 20, discuss the pain of manual recovery, and wrap up with lessons for a resilient future.
All right, part 1, the universal blue screen.
As this wry cartoon stock punchline points out, of course your computer crashed, you threw it out the third-floor window. Usually we perceive computer crashes as these isolated, single-user problems. And yeah, sometimes they actually are totally user-inflicted. When your personal device fails, it's a massive inconvenience. But hey, it's contained. You call IT, you reboot, maybe you lose an hour of work. But the event we're looking at today fundamentally flipped that script. It wasn't user error, and it definitely wasn't isolated. It was automated, and it was everywhere.
Which brings us to Section 2, the July 19th outage.
I want you to think about what CrowdStrike's Falcon sensor actually does. It uses AI and machine learning to automatically detect and shut down advanced threats. It's literally designed to protect systems, right? But on this particular day, as part of their regular release operations, a totally routine content configuration update completely broke the exact systems it was meant to defend. It triggered a cascading blue screen of death across the entire globe. And the timeline for this chaos was astonishingly fast. At exactly 0409 UTC, a rapid response content update for the Falcon sensor got published. It was really just meant to gather telemetry on new threat techniques. But immediately, Windows hosts running sensor version 7.11 and above started crashing. This kept happening until 0527 UTC when they finally halted the malformed update. That is a window of just 78 minutes. If your Windows machine was online and connected during that specific 78-minute window, it was impacted. Actually, Mac and Linux hosts were totally fine, and so were any Windows machines that just happened to be offline at the time.
Let's look at Section 3, inside channel file 291.
Okay, we really need to define this term because it's a huge piece of the puzzle. Rapid response content is what provides visibility and detections on the sensor. So the crucial thing to understand is that these are delivered as template instances. Basically, think of them as configuration files that map out specific behaviors for the sensor to either observe or prevent. They are designed to update how the sensor handles new threats without requiring anyone to actually rewrite the local sensor code. It's supposed to be a totally seamless, low-risk way to keep security models up to date.
Moving to Section 4, the mismatch, 21 versus 20.
So, here is the absolute core of the failure. The rapid response content gets published up to a cloud-hosted delivery system. Up there in the cloud, the content validator approved an update that contained 21 input values. But down on your actual local machine, the Windows sensor's content interpreter was only programmed to expect 20 input values. It's the ultimate square peg, round hole scenario. The cloud sent 21 fields, but the local interpreter only had 20 fields ready to go. Just a single mismatch number slipped right through the validation checks. So what exactly happens when you try to force 21 inputs into a system expecting 20? Well, it triggered an out-of-bounds memory read in a file called csagent.sys. Now, csagent.sys is CrowdStrike's file system filter driver, and it operates at the kernel level of the Windows operating system, literally the absolute core of the computer. When the interpreter tried to read that 21st value, it essentially read memory that didn't exist. And because this all happened in a highly privileged kernel driver, it wasn't just some app freezing up, it was a fatal exception. It resulted in an instant, unavoidable system crash, the dreaded blue screen of death.
All right, Section 5, the pain of manual recovery.
Let's talk about why fixing this was such an absolute nightmare. First off, you couldn't just push a fix from the cloud, because the computers literally couldn't boot up to connect to the cloud. Recovery was this brutal manual job requiring insane amounts of time and money. IT staff actually had to physically touch the machines. Second, for companies using virtual desktop infrastructures without proper backups, recovery was agonizingly slow. But maybe the most brutal compounding factor was encryption. To fix the issue, you had to boot into safe mode, right? But if a drive was encrypted with BitLocker, you needed a specific recovery key just to get into safe mode to delete the bad file. For enterprises with thousands of machines, managing those keys manually was just a monumental bottleneck.
Finally, Section 6, Lessons for a Resilient Future. So, how do we make sure this never happens again? Let's look at the actions being taken. For testing, we learned that missing testing matrices can cause total failure. So the action taken is heavily enhanced testing, local developer testing, stress testing, and specifically fuzzing, which basically throws unexpected data at software to see if it breaks. For architecture, the lesson is totally clear. Kernel crashes are fatal. The tech industry, and CrowdStrike specifically, is planning to update agents to use new security functions in user space rather than the kernel, which drastically reduces the chances of a system-killing crash. And lastly, management. The massive scale of this cascading vendor failure proves organizations absolutely have to run frequent, rigorous assessments of their third-party security providers. Which leaves us with this one big provocative thought. If a single mismatched number, literally just 21 instead of 20, can break the world's digital infrastructure in a matter of 78 minutes, how resilient is our interconnected future really? It's a pretty stark reminder of our deep reliance on centralized cybersecurity. We've built this incredible automated digital world, but as we've clearly seen, the foundations can be surprisingly fragile. I really hope this explainer helped you understand not just what happened on July 19th, but why it actually matters, and the monumental work required to keep our screens from going blue. Thanks for joining us today, and keep asking questions.